Okay, all set. Okay.
Okay, let's do that then. Well, I suppose welcome once again, and we are in the Data Cloud Bootcamp. I believe it's day number 6. The session is about data cloud harmonization, or also known as mapping and modeling. So that's a next logical step after getting all the data into the platform, and then start configuring consumption of it when you get inside the tool itself. So if you haven't met me on the first session, my name is Vladimir Silak. I work with Partner Product Success team, mainly focusing on the data cloud for probably almost 3 years now since it was launched. And my kind of part of my responsibility was developing that education learning journey for our consulting partners and internal employees alongside of my peers Arvin and Matt and Tracy. So thank you for giving me this opportunity. I know Elliot was meant to be presenting that today, but fortunately, I guess for me, he had some other challenges with time. So I'm going to be entertaining and talking with you today. I'm really going to walk you through the harmonization on the platform, explain what it is and what it's meant to be used for and how to approach that from the implementation, I guess, perspective if you're configuring the system. I'll do a very quick demo to show you a few points in the, or few other components in the tool itself, so you're familiar with what it looks like if you don't have access to the work today. I'll do a very, very simple quiz at the end of it and open up for Q&A as we normally would have. While I don't necessarily expect or plan to talk about something that is not generally available, just to keep the lawyers happy, I want to make sure that if I do mention something that is not generally available today, then please make sure that you make any purchasing decisions and investment decisions on the functionality that is publicly and generally available today. And there we go. The functionality of the data cloud, I think we talked about that from on the first session, is you've got multiple stages that you go through. And normally we're looking into data storage and data ingestion or data integration, bringing up all the different data sources into one single central place. And then we're looking into the next step that is really harmonization. And this is the piece that is very critical to get done right and done correctly, because it essentially enables all other subsequent activities in terms of consumption of data within the product. So if you think about unification, so combining all these different profiles into one single individual, which is called identity resolution. If you're looking into creating segments and activating the segments into different systems, if you're considering retrieving data from Data Cloud and presenting it maybe in the service console or just the customer profile information, all of these components, and there's plenty of others like AI and modeling and all the other things, ultimately all of the downstream activities that really fall into the act and activate, they all rely on data model. And therefore, getting that process done correctly is quite critical and important for the end success of the implementation. Harmonization itself, it is important concept to understand well, and from from within the product perspective, in the very simple terms, what we're trying to do is we're trying to take all of these different data sources that Elliot was discussing in the previous session from different sources and connecting them into one standardized common model, data model. Ultimately, think of that as you've got different expressions of the exact same data points, attributes, or entities. So, if you talk about marketing, you'd be talking about subscribers and contacts, which is really one of the interesting concepts in a way, because it does already represent that different expressions of the exactly same thing. There is a person behind the scenes, and we call them subscriber or we call them contact. We can have first underscore name, we can have first space name. They all represent the same thing, but they expressed and written out differently. And that's exactly where the data model comes into play and the data mapping exercise comes into play, because you take all these different attributes from all these different data sources and you map them into that, as I said, standardized or normalized, standardized common data model altogether. Why I kind of took a step back in the sense of talking normalize, I'll talk about that shortly. The very good analogy I found is one of our colleagues found a way to express and describe it, thinking of harmonization as being really a Rosetta Stone. In a way, what it does is, if you have never seen that, it's ultimately an ancient finding. There's a big stone that was having different inscriptions on 3 different ancient languages. One of them was Egyptian hieroglyphs. I think there was one ancient Greek, and I can't remember the third one off the top of my head. But ultimately, because the text was one and the same, we were able to establish ultimately almost translation of other languages and understand how they sort of form the language altogether. So in essence, we're trying to do exactly the same thing in the data cloud, because we bring data from service, marketing, commerce in this example, and we're trying to figure out how do we express all the entities that represent account, contact, lead, subscriber, customer profile, all of these different pieces of information in the exact same notion within the data cloud itself. So we kind of going through that modeling exercise, we mapping these different objects and attributes, and ultimately ending up with what we call a data model objects. This is the standardized view of all the data that is in the platform and expressed through the standard or custom library of objects and attributes. A very simple example here, and on the right you can see that Rosetta Stone picture altogether, but ultimately in the same of when we're looking into the e-commerce profile, for example, we've got these 3 different attributes. So we've got full name, date of birth, email address. What we're ending up mapping it into within the data model is you've got individual object with 3 attributes, and you've got contact point email object with 1 attribute. And this is the way we look into, okay, we've done it for commerce. How is it different from marketing data point? Well, it's no different. We're mapping to the exact same objects. We've got first name, last name, we've got birth date instead of date of birth, then we've got email instead of email address, for example. But what you can see, it doesn't matter what is the source on the left and how it is expressed at the origin system. We translating that naming convention into standardized common fields. So we've got one set of attributes that is formally known, that is natively available as a standard set of objects and attributes within the platform, and then potentially we can extend that should we have a specific business need in case to express something that is not available out of the box. But that's the whole idea. So we're translating ultimately what we've got in the source into one single common notation, if you call it like notation, translation, interpretation, just naming pattern, standard naming pattern for all the data elements. And that's the model that we're going to end up using within the data cloud once we start going through different activities. Very, very important thing to understand conceptually, if you look from the process perspective, whether you're configuring or just even understanding that when you bring the data into the platform, you effectively creating a data source object, and I believe Elliot covered that. The data source object is the raw representation of the data. Then we transform that into the data lake object, and that's ultimately what you see as a first point on the data lifecycle within the product, where you see DLO, data lake object, when you go through the different streams. And if you go into the things like a data explorer, you can see the actual values. Now, they still kind of carry on that naming convention that you define when you're creating a data source, or when you're creating a data stream rather. So you've got these fields, attributes. Yes, you can change the name and labels and titles, but ultimately they still represent the data from the source origin system. And then the modeling and mapping exercise, that, as I said, next step is when you actually take the object and you start configuring like where these different attributes fall into within the model itself. Once we've done the configuration, once we done all that particular mapping, that's, as I said before, we can start looking into using it for unification, for insights, for activities within the data cloud, and outside of that through segments and activation and other data points or actions. Because now we have one single source of how to talk to data, how to extract it from the platform and interpret that. So it's a really interesting and I think powerful tool in a way, because it's done through the user interface. It does allow for a very simplistic kind of approach to do the configuration, but at the same time, it empowers us to do a lot of different things. The key thing is just another call out to the point that harmonization is not the same as unification. They're 2 separate things, and harmonization is really our data mapping and modeling. It's normalizing, it's standardizing naming conventions, field formats, different relationships within data points into one sort of standard and potentially custom data model, extended custom data model. But unification is the subsequent process that you will learn about in the next and following sessions, is taking that information and then start recognizing people behind or accounts behind all of these different data points. But because it's now one single kind of like library of attributes, if you will, it's quite easy to start actually working with data, because you don't have to worry about the source. You don't have to worry about what taxonomy and naming convention was used in one system versus the other. How do you match people in attributes when you start configuring these different matching rules? It's all one single naming convention, and that's fantastic. So it's quite easy to consume it. Now, I mentioned it a few times as I was talking about that, standard data model, and sometimes I mentioned it could be custom data model, and why would you look into using one or the other? So from our perspective, when we start developing Data Cloud, and at the time it was known as a slightly different product in terms of name, we were looking into CIM, which was a common information model or something along those lines. Ultimately, we decided to publicize that and make it available to other companies to work on the standard across the naming convention, the objects that we use. So that would allow different platforms interoperability in terms of data exchanges without making integration work very complicated and hard for people, because we wanted to have a single notation of all these different objects and attributes that represent business and hypothetical entities in terms of data that we operate on a day-to-day basis. And therefore, why do we need to have a different way to express them when we can standardize that? Unfortunately, there were not really many volunteers and organizations that picked this up, and therefore we brought it back in-house, as I call it, and call it Customer 360 data model. So that's the standard, and rather, I guess, our view on how to define that canonical or rather standard model across all our products portfolio. And then when we start working on it, we decided that we're going to work towards that process of changing, updating, or unifying these different data points and data elements within Data Cloud through that conversion, because we now have one single library of all the objects that we want to represent within any product, whether it's marketing, commerce, or CRM. We have list of attributes. We define rules and explanations and business outline of what each and different object meant to represent, and then we start configuring and creating them. So that is one thing that you would need to get familiar with as you go into. There's a standard set of different objects and attributes. They represent portion of that canonical model. So we implementing them as we go. And you will need to know what are these different objects represent and what are the different attributes exist with them. Main reason for that is, especially if you work within Salesforce portfolio of products, when the data is coming into the platform, the standard data model allows us to deploy certain configurations without involving you as an end user. Because if we know that account and case and lead and opportunity maps to the same standard objects that we design in Data Cloud, because we have that common reference system, we can map account from CRM to the account in Data Cloud. We can map individual or contact to the individual rather, because we know what are the effectively relationship between different fields and what is that metadata that explains us like what information is being carried in object A to object B to object C and across different fields. So we're doing a lot of this work for you and therefore simplifying the whole rollout of the platform solution, because, as I said, because of that single standard within the product portfolio. It is absolutely not bring your own data model. So there is a bring your own model, bring your own lake concept. So we're not talking about that. We're just saying, when you start configuring, when you start developing, when you're implementing the solution, you don't start from empty space. There's plenty of different objects, and even this release now bringing up even more so from industry perspective. And therefore, before you get on the adventure of configuring and creating something custom, you have to stop, you have to pause, and you have to think about, well, I do have standard objects and I do have standard attributes. Can I map what I'm trying to bring into the platform using one or more of these different entities? And therefore, as I said before, knowing the data model objects within Data Cloud is quite important and significant for successful implementations. There is a set of attributes, or sorry, rather, set of objects, the data model objects, that you must be familiar pretty much for any implementation. And they focus primarily on the key aspect for unification. So you've got an expression of individual with mentioned attributes. You've got contact point, address, phone, email, app, social. So one of these objects that you'll need to use and you need to map in order to configure resolution. And potentially one of the optional ones would be the party identification. So let me kind of quickly walk you through what do they all mean. So because we're kind of starting on that, individual, it's a representation of a person. It's effectively self-explanatory. Any individual that you want to consider to be a person and you want to collect their attributes and use them to unify and recognize multiple profiles linking to one single person, you want to map to that object. So they normally represent things like first name, last name, some kind of identifier for that individual. And there could be different identifiers coming from one system, like could be 3 contacts in Marketing Cloud or 3 leads and 1 contact in CRM for me. That's absolutely fine and normal. We bring all of these different identifiers. We map each of them separately. We'll have the separate first name, separate last name for each of the records, and potentially other attributes. The fields that you see across different objects, they represent the minimum set of attributes that you have to map in order to use this object in the identity resolution. So next commonly used ones would be contact point email. It's one of the common things that we're matching people using email addresses. And therefore you need a primary key for that and you need an email address itself. Now you can see that there's a set of these blue fields or like a lighter colored fields that says party, and that relationship that is drawn up, it's effectively mislabeled field that is representing individual ID. If you are working, and I'm showing you that perspective, this is for using, I guess, individual-based identity resolution. If you're working with more or less B2B context, then you would be looking into potentially using accounts, and you're doing matching on the accounts. In this case, you will switch the object, the individual object mapping into account, and all the party fields will still map rather from individual to the account ID, but the construct and the concept remains the same. So if you need to do mapping on the email address, or rather matching on the email address, you map contact point email. If you need to use phone number to recognize people, like could be have different expressions of the first name, last name, different IDs, but you have the same phone number, then you need to map contact point phone. If you want to do physical address, then you use contact point address and so forth. That's the kind of the construct and concept, the way it sort of works. Party identification on its own, it's a separate object that is interesting in the sense that it allows us to use external identifiers that has been used to identify people in different systems. A very common example of what it might be, it could be your driver license, social security number. It could be loyalty ID or loyalty membership number. So anything that represents a person that has a specific identifier assigned to them. It could be an MDM ID, it could be data warehouse ID, but ultimately some kind of system identifier that has been generated and assigned to that individual. And we want to use that because we know that when the data comes from certain data points or data sources, it already has that identifier. We don't have to do any matching. All we need to do is just link these data points because these profiles have been matched elsewhere. That's main reason for using that specific object. Again, it's not mandatory, but if you configure identity resolution, you will be reminded of that again, that you need to map either individual and one of these contact point channels objects, or individual and party identification in order to do some kind of unification and resolution process altogether. Now, in addition to these objects that I mentioned, that they will be required for pretty much any implementation, any configuration, we have a number of other subject areas with respective objects underneath them. And again, this is not by all means a comprehensive list, but these are the common ones, at least from the perspective of we've got retail maybe as we started, there's service objects that we've got, there's sales objects that we've got, have financial services objects, and there could be more and more industry subject areas coming into play. So we'll start seeing more and more of them coming through. These were, I think, originally implemented almost from the get-go, and therefore I usually refer to them. But always go back to, there are 3 sources that you can find the details and information about all of these. One, you go into the help and data cloud section that has a list of all these different subject areas and references to a few other places. Second would be developer side, where you've got more detailed breakdown of these different objects, including fields and some relational information. And then the last would be the architect at salesforce.com, where you've got diagrams with template galleries, and they include relational model. They've got like subject areas with different relationship between the object within different subject areas. So you can explore and study and learn. But for any implementation, again, it is important to understand what is available out of the box before you jump into creating your own customized objects altogether. In addition to all these, there's another big point that we often getting asked about is the consent model. Again, this is not new in the construct and concept of saying this consent model has been designed probably good 2-3 years ago for CRM itself. And similar to CRM, we're kind of transcending and evolving and exposing that notion and bringing it into Data Cloud. So you now have matching objects within Data Cloud for expressing different consent points. And if you ever explore that, there's different levels of consent that can tell you, different granularity of permissions of individuals, whether or not a business can have any conversation with them through different medium and means, so different channels. In these cases, you can see you've got global options, you've got engagement channel consent, you've got contact point consent, because for an individual, you can have 2 different email addresses, could be private and work email address and so forth. And then there are things like even like data use purposes, for what purpose you can potentially talk to me and from which brands if you need to. So all of these data points are included. You have an option to configure them, but what we found is by far not a lot of customers would be able to configure their data mappings into that model in essence to consume all of these different levels. And that's absolutely fine. Remember that one thing when you're working with Data Cloud, this is a system of storage and reference. So we taking the information, we're storing it in the system, we're defining these relationships and mapping, but we're not orchestrating or mandating that this is the way the data has to be structured. You need to make decision on how you structure it, and therefore you use the objects that are required for your representation. If you have a gap somewhere, that's fine. You just need to make sure that you understand how that relationship works, and if you're missing 1 level or 2 levels, then you just need to know that that's the way it works in design. Now, in the same terms, when we sort of look into that, one thing to say is it is very important to understand the difference between DMO and the source object, especially if they match by name. So in this case, and I usually talk about that on that particular slide, mainly because if you work in CRM space and you bring this information into Data Cloud, you would say, well, hold on a second, we've got individual in CRM, we've got these different consent objects in CRM, aren't this one and the same? Why do I need to map them? And the answer to that would be is reminding you that when the data comes into the Data Cloud, it is coming through data stream object, then data lake object, and then we mapping it and exposing it into data model objects. Now, the fact that you've got the same name for data lake object and data model object doesn't mean that they are one and the same. They're 2 different things, and data model object is something that expressed and resides in Data Cloud, while your source objects, they coming up from the different system and they serve like almost like a staging tables to bring the data in, but they absolutely not one in the same piece, and that's quite important. When you're comparing them, we started with like, what do I use? Do I use standard versus custom? And the right answer in all these implementations that we're seeing and doing is that it's both. Most of the time, you're going to have some kind of hybrid model, meaning that you've got you normally attempt to express all your data through standard object as much as you can, and then anything that is missing out, whether it's separate object, often that would be based on the industry, or some of the attributes on the standard object. You might need to express some of your data points in a different way. That's absolutely fine. It's super easy to do, to extend these attributes, to add them, and therefore we encourage you not to be constrained by standard model, but before you start going into custom, your thought process should be use as much standard as you can, and then jump into the customization, whether you're doing objects or attributes or both. You've got permissions, and obviously you've got functionality that allows you to configure data relationship between different objects. So that's absolutely fine. And in the same way, you can tweak and adjust the existing permissions, relationships between existing standard data model objects. As long as you understand what you're doing, as long as you understand documenting that, it should be absolutely fine, because it needs to represent your business need, your business requirement. Therefore, it's a starting point, but it's not the definitive and the only right way to do things. As you get into modeling, one of the sort of concept that is not necessarily related to Data Cloud itself, but it's understanding in general that there is a different way to structure your information when you bring it into different systems, and when you express it and extract it from different systems. And that's normalization concept that is applicable, as I said, broadly within the different data domains. Ultimately, if you kind of think about the data, normalized data and not normalized or denormalized data, it's two different paradigms. And one of them is, if you look on the left-hand side, the normalized data view is the approach when we're trying to separate different conceptual logical data pieces into objects or tables, ensuring that each piece of information is only stored once. There are different levels of normalization in traditional database concept, and if you ever study that. But ultimately, from our perspective, we're trying to look into you logically group data, you avoiding the need to repeat it and store it multiple times in different tables or in different rows within the same table. So you'd rather look into how do we improve the efficiencies, remove redundancies, decrease the storage, and making sure that there's a performance element that's applied when we're storing and processing, or rather querying and retrieving information when we're doing different combinations of joining the tables together. Denormalization, on the other side, is a common still approach working with data, but the concept and approach to that is when we're adding more attributes into the same table as a field, or just directly as an attribute if you're talking about objects, rather than thinking about let's create a new table. And it does provide a bit of a different sort of benefit when you're running a single query on a single table, because you've got all elements at the hands, but it does introduce redundancy because you're going to be storing the same information multiple times. Like if I try to visualize it in a bit more acceptable terms and norms, I guess, if you look into left-hand side, you see that there's a customer object, there's a contact point email, there's a sales order that is then linked to or related to sales order product. So the information in this case, if you look about individual, we would have a customer record to represent the person. Then that person can have one or more sales orders, but we're not going to repeat customer information on every single sales order, even if it's the same person. We have one field that will allow us to reference the same individual and then store the information in one single table, alike to any others. Versus if you look on the right-hand side, where the sales order would contain mixed set of attributes that comprise of customer details as well as product details, as well as transaction itself or sales order details. So that's very denormalized approach. The interesting thing is, if you look at the right-hand side, there is that one word that says intentionally introduces redundancy, because it is done by design, and there is a concept of bad systems when you do a system level design, but when we start talking about use cases specifically around integrating different systems, if we talk about generating reports, if we're trying to extract that information, and we know that we're going to be doing it almost like on a day-to-day basis, this is part of the business process, that sometimes that intentional denormalization is actually a design decision. It's something that is done purposely, and therefore it doesn't mean that people who design it were bad designers. There's a decision that someone has to make, and therefore you just need to understand that in different systems the data will be stored differently, expressed differently, and you have to work with it. How is it relevant for Data Cloud? Is Data Cloud always stores everything in normalized form, and therefore if you're looking into majority of systems, it happens to be that way when we bring in the information into Data Cloud, and especially if you're doing flat file exchange, then you end up having information extracted in denormalized form. And that is something that you have to think through. How do we actually map it into the normalized model? Because we've got mixed payload and it doesn't always represent one thing or another. So from our perspective, if you look into the data model objects specifically, they're highly normalized. They're designed, by design, they're done in a way that you've got one expression of an entity, and then you've got relationship that allows you to go up and connect to different data points. And that simple example, as I started with individual and contact point email or contact point address, focus exactly on that particular challenge. Now, at the same time, we do have denormalized state. So when you bring the data in, that most likely, most of the time we've seen it, it's becoming denormalized, it's coming denormalized. So your data lake objects that come from different systems, they will potentially be denormalized. When we creating segments and we start activating the segments into external systems, when we start adding different attributes potentially from different tables, then we're flattening it into one single payload. So think of that one row of information with multiple attributes. All of a sudden, we will technically denormalize the information because we're doing that flat, we join the tables, we take that information and push it together into one row. So if you think from the destination target system that needs to accept that payload, it has to understand that the data is coming denormalized, and depending on how you work within that system, you may or may not need to do a similar thing like we do in Data Cloud, which is converting that and normalizing it and kind of mapping it to whatever the target entities would be. So there are a few things that even within Data Cloud you'll find they're differently expressed and work differently. And then the last thing that you need to understand as a part of all of that modeling and the concept of making sure that you get through how it works is primary keys, foreign keys, and cardinality, because these are the things that really needed for us as a foundational understanding of how to work with data in this product. So primary key, I hope that's not news to anyone. It's ultimately the one or multiple fields that express unique record for a given table or object. And in our case, what you will find is in data model, all primary keys are single field. So you cannot define a data model object that has a composite primary key. So that's one of the constraints when you think about bringing new information into the system. You have to straight away remember that if you're doing mapping, what is the primary key at your source table or object that you now configuring as ingestion into the data cloud? Because primary key on ingest is different from primary key on how you map it into the data model. You can have maybe more than one field that is primary key on ingest, but you need to get to the point where there's only one field that we can map to into the data model that's defining uniqueness. And that's where most of the time formula fields will come in. So that's something that you do as a transformation on ingest. Foreign keys, they are effectively fields that relate to other data points. In earlier diagram, when I displayed you, remember there was the party field that related to individual table. And therefore, similar in this case, you've got sales order that link to the sales order ID from the product. You've got sold to customer, which relates to individual. And then on the product, sales order product, you've got product ID that relates to some SKU or specifically ID on the product table. So these are relationships, and they've got different cardinalities, meaning that for a given sales order, there could be more than one products that included in this order. And that's where you see one sales order has one or more, which is one to many, relationship to the sales order product. If you look into the customer in the same way where individual can have one or more sales order, or zero or one or more sales orders. So that's another thing where you've got one to many again. And direction just really tells you, from which kind of side you've got one or more objects represented for a singular relationship altogether. So there you go. You've got primary keys that represent unique records. You've got foreign key fields that are used for linking the different tables between each other or different objects between each other. And cardinality is the relationship between different records in each of the tables. So that's a very simple expression of these different concepts. And if you look into the practical example, because all of these is great as a theory, like taking it into a bit more practical play, let's have a look at the typical denormalized example. And I love this example because it represents something that we have almost, by default in Salesforce CRM. If you ever work with CRM, you would know that there is, let's say, a contact or lead, normally has first name and last name. There is at least one email address, but usually there are two. Then you've got different addresses. You've got billing address, shipping address, and you have phone number, mobile number, and could be other number too. And therefore, you've got one row of information that represents all of these different attributes. Now, from our perspective, when we start looking into how do we need to map this information, so you've got this ingested. Let's say this is a Salesforce contact object that we're bringing in. So you've got one data lake object that you're working with. Now you need to map this one single data lake object into the DMO, one or more. And interestingly, you can see that anything to do with person goes up into individual, which is pretty straightforward. Both emails are going to be going up into the contact point email, similar to address and similar to phone. So you've got 6 different contact point records, ultimately, joined together that have to go into separate tables or separate objects. Now, for us, what is important to think about as we start looking into this particular example, you've got one single entry and it will have a contact ID. So here it's represented with individual ID 481002. Simple, easy. Now it's not that easy because when we start talking about primary keys and foreign keys, primary key on ingestion, when you configure data stream, you have individual ID. That's relatively easy and everything is done. So let's look, how do we start thinking about mapping it into different objects and how many primary keys do we actually need to represent this information? So you have, for individual, we need to be representing that person, and therefore we need to look into having one ID for person. We've got it. For email, we have 2 different emails. For phone and address, the same story. And each of these records need to come up with their own ID, unique ID. Because you can't use the same individual ID and ingest the billing address and shipping address as a separate values or separate rows of information using the exact same primary key. Ultimately, only one of them will survive. And the same applies for email, same applies for phone. So that's a bit of a challenge that we're going to figure out, how do we do that? Because at the source information, these pieces of data don't exist. And therefore, we have to figure out how to create these, or where do we source them? If you bring information from third-party systems, it's part of the design decision that you have to make. But if you bring it through Salesforce native data points like connectors, it's exactly the same challenge and exactly the same thing that you need to consider and think about that. So if the attribute doesn't exist in the source information, that we have to think, how do we create that? And that's where that formula field comes handy, because we can use concatenation, maybe some other methods to create ultimately unique values in order for us to result and build up particular identifier that we can then use as a primary key. So a few examples here, you've got individual ID combining with something that says work email address, or you can look into email 1, email 2. So different options, and you can express them differently, but ultimately you will need to create 6 formula fields in order to do the mapping of that one single row of information. And this is just preparing that, like the data when we're creating this data stream, in order to be able to do the mapping. Our second challenge will come into that understanding of normalized and denormalized. So, and then we'll talk about that as we go through the examples. But few things to know when you're talking specifically about creating these primary keys with the formula functions. You have to understand and think what you use in order to generate the value. So if you're going to create these 2 different email IDs, and then later down the track there will be a change of email for personal or work email address, all of a sudden you generate a whole new primary key, and that's not necessarily what we want. So being mindful of, if you use a field, what is the likelihood of that field to change over the lifetime of the record? Because if you're using it as a part of your primary key, so it's a composite key, you're ultimately creating a whole new role, a whole new record, and that might not be the outcome that you're looking for. There is a function that is called UUID, and sometimes, you would think that, hey, this is a great option. It will generate unique value for us. This is awesome. I'll use that, and that solves all my problems. The challenge, though, every single time you do the ingestion of the records, that UUID function will generate a new value. So every single time we run it, that's a new value that's coming into the condition. So if you update information, if you bring specifically profile details, you don't want to generate value every single time. You want to be a bit more persistent. So if we know that the member ID or individual ID is permanent, and we just concatenate and say work email or individual underscore personal email, the text, actual literal value of the work email or personal email is not going to change. You can change the values, but they're going to remain the same. But therefore, that might be one of the options to consider. And specifically with UUID, you definitely don't want in this particular view. or in this particular use case. Now, on the contrary, when you generating events, so a very good example would be, so we're storing information that comes up with, so it represents like a stream of behavior. So think about clicking through the different web pages on the website. Because we almost never update the events in the case, in this specific case, UUID function could be very handy because it will in fact generate unique value, but because you know that data only comes as a new piece of information every single time, you are not concerned that you need to update the event and therefore you might potentially create a duplicate value. No, it's not the case. So you kind of play with all these different options, but as long as you consider what and how you like what information, how you combine this information you use to generate these primary keys on ingestion within the system, then you'll be fine. It's just more of a consideration. So all you need to do is just think through how do we do that and what do we use for different pieces of the puzzle. Now, if you think about overall flow, how do we do the mapping, right? We've got design phase that we differentiate and build phase. And we purposely always guide and coach that the fact that your design phase really requires some time to get it right. Because as you've seen, it seems very easy on the first view, because you've got the data coming up from CRM, there's one row of data. How difficult could it be? And then you realize that you actually need to think about these things that called primary keys and foreign keys and relationship and normalized versus denormalized view and what to do with different things and where exactly would you be doing that. And therefore, you need to, we would always encourage you to go through a good audit of your source system to understand how the data comes into Data Cloud. What is the, I guess, original shape and form, how it's expressed, what are the different keys that are being used, are there any options for the information to be complete, incomplete, nullable, non-nullable values, and so forth. So all of these different elements ideally need to be documented, explored on the sample data set, and then as you get into kind of preparing yourself for implementation, you start shaping what we would say a solution design document that effectively tells you how would you map the source data to the data model, whether it's a standard or hybrid, and what are these different mappings across different fields that you need to do. So doing the thorough audit, understanding that normalized, denormalized, understanding how you need to transpose and transform if you need to do that, because we do have ability to transform and take one row of data and split it into more than one. This is definitely an option, but it is a step that you have to consider and design for, and therefore planning and doing that design is very, very important and significant thing. So we would always encourage you to take your time, think through all of that, all of these different steps. And there's one extra thing to consider. It looks like simple, okay, if I've done a mistake, I just go back and change that. It might not be as simple as that, because if you remember, I mentioned that you're configuring data model and then it's being consumed in all other activities when you go into acting on data. If you need to make any changes, you will have to consider any use of your existing data model before you're allowed to make this change. So if you want to remove the mappings, if you want to remove the object, but you use it for an existing segment or activation, then that's a problem, and the system will tell you so. If you use the attributes in the individual on the individual table for identity resolution and you're trying to change them, again, the system will tell you, hey, I'm already using that information. You can't just go up and change that. And therefore, all of a sudden, that small change can actually become a fairly time-consuming exercise, because you need to think of the steps, the order and sequence of execution of these different changes. So as the initial implementation feels very easy, very intuitive, you jump in, system gives you a bit of a recommendation on some of the fields, but when you get through navigating it and actually analyzing that, you realize there's more behind the scenes there. Doing the actual configuration, it's relatively easy. You'll find that the system gives you plenty of help as well. There is a suggestive mapping of different attributes, and therefore it makes it easy if you know what you're doing. If you have a plan, if you have that design, it's relatively easy to go through the tool and configure it and have it ready. If you think about end-to-end sequence, and just reminding you mainly to kind of re-emphasize the point that ingestion is different from mapping. You've got all the data comes into the data streams exposed in the data lake objects, and these are the ones that you then map into the standard or custom attributes and or objects and define relationship between them. So that just like two separate steps and two separate things. Why as well it is important is because If you don't map the information, the system will not see that, and I'll talk about that shortly. As you're doing mapping configuration, it is good to think about consumption in terms of how would you use these different attributes. So you're designing the data model object or use standard, and then you realize that in some cases there are fields usually similar to drop-down values that you have in CRM or select list if you've got them on the web applications and other systems. Ultimately, some values that are just repetitive. We're normalizing it. Okay, there is a particular product that we consistently, or category that we consistently use and refer to. And therefore, the system said, instead of you knowing the values in this particular field, you can actually choose for it to generate a value suggestion. So ultimately, the platform will profile your field that you map to have a value suggestion enabled on. It will take up to 1,000 most frequently occurring values if there is more than that number, and put them into a dropdown. So when you go up into the segmentation canvas and you start working with that in the user interface, you will realize that instead of you needing to remember which particular value you want to use, you can actually click on the dropdown and choose from the suggested set, while you can still type at the same time. Relationships are defined pretty easy again. They are done through the user interface. So you're configuring the model and you can go up into details of the object and see the relationship, or you can configure it as you go and do the actual modeling configuration at the same time. The expression, you've got, as I said, object on the left, object on the right. You've got fields that map to each other, and you express the cardinality, whether it's one to many to one, depending on the direction. Again, similar to primary key, notice that in this case, we're using a singular field. So there is no way for me to say, take one object and have more than one field that is then relates to other object and singular or multiple fields. So that whole thinking of primary keys, as I said, applicable to what is the composite versus what is a singular field one, you have to kind of transcend down to foreign key concept as well. And therefore, when you're configuring relationship, they can only be field to field on different objects. You don't use multiple items. All right, few examples to walk through briefly. It's just more to give you an idea. You look into two different sources of information. You've got one from data extension in Marketing Cloud, and second part that comes up from the contacts object in CRM. Similar sort of nature of information, but different ways of expressing the field names. You can see you've got like contact ID versus subscriber key. You've got first name, last name, slightly differently expressed, and so forth. Some information might exist in one source, but not the other. It's all absolutely fine. So you choose which fields that you need to map to, and you flag them into respective fields on the target individual DMO in this particular case. If you look into two data source objects and one data model object, so again, you've got web orders coming up from from the system, and then you've got offline sales. Again, you've got different types of attributes. Some have some information have more details, but we may or may not necessarily use that. And therefore, again, you're finding what attributes are necessary and how to translate them into one single object within Data Cloud itself. So they all go into the sales order, and then you're looking into how you do that actual translation from different source fields into one same standard connotation and expression of the attributes. If you look into the web sales order details, again, there's sales order product. They sort of have a good match, and it's, again, relatively easy to establish them, but you might need to do and rely on data audit when you go and inspect the values in the field, rather than having necessarily a linkage based on the field names. And part of that exploration of the raw data helps you to establish whether or not there are different keys and what keys are really unique, in essence, to say, do we have a single field for the primary key and that's really unique, versus do we have a composite field? And we need to think about what really in this particular example would be the primary key when we start ingesting them. Because if we're looking into web sales order details, you can see that there is same order ID repeated twice because there are two different SKU numbers that were included, so two different products. So when you're thinking about ingesting that, you can say that your primary key could not be an order ID. You actually have to take maybe an order ID, a SKU, and the customer ID if you want to, or you can just do order ID and SKU to make the primary key. And then that value will be then the true primary key for data model mapping too. All right, there's another example, and it's something that I was referring to with regards to normalized tables, because you'll find that more often than not is you've got one row of information, but you need to transpose it into more than one. So this example, you've got every subscriber has first name and last name, but they've got two different email addresses, and therefore when we're doing the mapping, because Data Cloud is normalized, you would be looking and saying, okay, I want to get the subscriber key, first name and last name mapped to individual. That's fine. And then you go and say, well, let's just, for the sake of it, use primary email as a primary key, and then primary email value itself as the contact point email. That's fine. But then secondary email address is getting lost because you can't map the same record more than once into the same DMO. So that relationship is really not quite working out for us. In order for us to correctly map all these values and have them available within the data model, we need to transpose that information and ultimately generate a separate row for every single email that we will then use and map into the contact point email. So as you can see, we're using formula field to generate the ID, and then we're using the email address to effectively as a value that we want to store. The subscriber key will be used as a foreign key like party field, and it will link to the individual and allow us to, in this case, have 2 emails per individual stored in the system. So that just kind of reiterating normalization. A few more important points, and I'll do a quick demo as I promised. So one big thing that I always remind people about is if you think about data source object, you don't really see it in the platform. You don't have access to that. We don't expose that. It's the data as it comes into the platform, and we store it, but we don't give you visual user interface to access that. You go into the lake object is ultimately going through transformation. So if you've got these formula fields, if you have the name changes, like all of that transition and transformation have happened as the data made it into the platform. And that's the first kind of like object, as I said, as you can see, if you go into the Data Explorer, and you can access and explore all these data points there. Data model object most of the time is not the material, like it's not the materialized table. So ultimately, when you do the mapping, what you're doing is you're telling instructions to the platform on how to query all your different data lake objects when you look at the individual or sales order or account or opportunity. Because if the sales order coming from more than one system and expressed differently, I want to go into one single sales order and see all of them from all these different sources. But the system doesn't copy that information. It doesn't store it separately. It just really goes up and in real time looks at all of these different objects and gives you that view. So it's non-materialized view. It's access in real time. And it is important for the understanding when you think about if I want to delete something from the data, sometimes all you need to do is remove the mapping between the data lake object and data model object. And the information all of a sudden is no longer going to be available to the platform, because every activity that we use downstream going to use data model representation rather than go into the data lake object. Same construct applies to the point of category. I believe Elliot talked about the category when you create your data streams and you define, and you've got profile, engagement, and other. The DMO typically does not have a category pre-assigned to that. So it inherits the first object's category that is mapped to that particular DMO. If I take sales order, like technically supposed to be engagement, and I map it to, by accident or intentionally, to the object that was configured as other or as profile, then the system will recall it and say, okay, now that particular object is that category of profile or other, and you won't be able to map any other ones. We did add some flexibility. You can interchange other with, or you can rather say map profile to profile, and you can map other to profile categories. You can mix engagement and other together in terms of mapping, but the DMO itself is important and significant, especially when you get into the consumption for segmentation purposes. But mapping wise, if you configure it as an engagement, then you can only map engagement. And if you're trying to map your object, but you're not seeing anything on the DMO selection, most likely problem is that you've got different categories and they're not allowed to be mapped together. I talked about interdependencies, and when you configure something, it kind of like reiterating. If I want to remove a mapping and remove the data model object, the system will tell me if it's being used somewhere. So again, when you do your design, when you're planning for implementation, one of the good reasons to think about your design and what needs to be configured and how is to ensure that when you start configuring other activities and later you want to make a change, you don't have to go and remove all the other configurations in order to change your data model mappings, because it could be quite an extensive exercise in terms of time and effort. All right, let me take a quick pause here. I'm just going to shift the gears and switch into the demo and show you quickly the platform in the sense of how the mapping is done. So you're hopefully familiar with the interface. I just wanted to show you a couple of items when it comes down to this specific view. So when we go into let's just say, I don't know, e-commerce line item, maybe not the best object, but nonetheless, you go into as a data stream. We can see all these different attributes. We can see configuration, but here on the right hand side, you will see data mapping section. And in my case, it's already mapped object, so I've got that relationship defined. But in a way, when the system kind of gives me that ability and opportunity to look into mapping details, all I'm doing is I'm getting the chance of taking all the attributes on the left-hand side and mapping them to one or more objects on the right-hand side. So in this case, it's a pretty straightforward, mapping between the e-commerce line item and the sales or the product. But you can see that some of the mappings are not necessarily the same by the name, and that translation happens as I map to the data model relatively with me clicking on left-hand side and choosing the attribute on the right-hand side. You can see that there's a connotation of custom field. So if I need to create another field for adding some information that is not there in the system, I can click here just right within that object. It's a standard object, and just add an attribute. I need to provide the label, the API name, and I need to choose one of the data types that exist in the system, and that's simple as that. Earlier suggestion, remember that thing that we were mentioning, that if I want that attribute to be selectable through, as a drop-down option instead of me typing it, then I can choose, tick the box, and the configuration is effectively done. Adding objects is, again, really straightforward. I can create some custom objects within that interface, or I can choose one or more existing ones and kind of do the mapping. So as the system kind of loads up the list, this is engagement object category or other object, and you will see that the system will kind of respectively figure out and say, I can only give you objects that you can map that category to, preventing me from making any mistakes. So that's where I said, if you want to look for something that is not necessarily available in the platform, then one of the questions could be whether or not we've misconfigured the category. Custom data model is where you can create custom objects. It's, again, pretty straightforward. I can click plus, and the system will give me a prompt to generate. And normally, for the first time when you do that, or rather not for the first time, but when you're doing it from this interface, it will make a copy of the data stream using both field label and field API names. It will inherit the same data types as you've got and define the primary keys for you. So it's quite easy, as I said, to get configuration done and extended should you need that. And then once the object is created, you just kind of come down to this screen and you're effectively done. If I look into, let's just look into maybe contact, it's probably a bit more interesting example because it will map to more than one object on the right-hand side. And this is kind of goes back into our normalized and denormalized conversion, right? So the contact itself has 25 different attributes that we have mapped, but it has a bit more because a bunch of them I did map in my system. But you can see on the right-hand side, they span across different data points. So we've got contact point address, we've got contact point email, we have phone, we've got individual. This is our, primary view of that. We do have loyalty information coming from this particular object too, and goes into details. And we use party identification. So in this case, we will figure out how to do the unification, and we're using, as you will see here, the loyalty ID number as our key that we would like to use for matching. I'm not focused on that for too long because there's a separate session for that, and you can go up and explore it. Now, often, as I said, you'd want to know what objects are available in the system and how to work with them. So if I come here and change the view from map to all, that's one way to start exploring without kind of going too much. At the very least, if you're doing, for example, like financial services implementation, there's plenty of objects that you can find that ultimately exist already in the system in terms of definition. And while they're not mapped, but I can map to them, I don't have to think about creating them. And if you know that they exist, if you know what they represent and how they're structured, then your design exercise becomes easier and easier and so forth. There's another interesting view here is if you switch that model to be looked as a graph. And it's a good exploratory view that helps us to look at the different objects that we have mapped and how they relate to each other. So I can look into when I'm doing my mapping, and if there's a lot more objects than I have here, sometimes it could be difficult to navigate and visualize all the different relationships. So this view helps me to visualize that, and I can look at all of these different objects and see that my individual map to the loyalty program member, as well as case, rental preferences, and a bunch of other different objects. And if I want to explore it, and if I want to look into more details, clicking on the object takes me straight into the definition of the data model object. It gets me into the view of all the fields. It gets me the list of what is mapped, what is value suggestion, and then all the data streams and data lake objects that have been mapped into this particular DMO. So you've got that information, and relationships are going to be expressed through a related list table that has objects and fields and cardinalities pretty much defined for each of these relationships that we've seen. So that's more having them listed out rather than visually seeing what are these different objects that they connect to and how they relate to. So yes, a few things as you kind of considering potentially doing the configurations is looking into, if you use, as I said, standard, if there's a lot of matching in terms of field names and API names, then when you get to the mapping interface, when you do the first modeling, the system does suggestion for you. So it will pre-map configuration. And in some cases, it could be risky, and therefore don't always rely on that as this is being the right way. You always need to make sure that you verify at the very least all the mapping that system does for you. Without having the mapping done, you won't be able to go up and use any of that information if you go into like segmentation, if you go into actions, if you go up into identity resolution, because all these other activities, they ultimately work with the data model objects. They're not working with your DLOs and data sources. So all the streams and legs are effectively staging steps in order to make data ready and available on the platform for all downstream activities. All right, I think this is really all the items I wanted to show, and I've got a couple of more things to share with you before kind of switching into Q&A. So as you go through the other learnings, there are part of that, as I said, trail mix for preparing for the consultant credential. There are a couple of modules that are related specifically to modeling and an overall overview of the data model for you, as well as there's that lesson that is a bit more custom. I would encourage you to take all of them and go through. There is a knowledge check as well at the end of it, but this is more for making sure that you understand there's more to learn and go through. And I do have a very simple quiz that I'd just love to run before we get into Q&A. So I'll ask you and encourage you to use chat probably when I show you the questions. I haven't really set up a quiz or anything. It's just more a bit of a fun. So 3 questions. The first one would be, based on what we learned today, what is the purpose of harmonization? There's 4 different answers. I would just ask you if you don't mind dropping into chat, A, B, C, or D, whatever option you think is the right answer. So we've got B, B, B. Oh, everyone goes for B. I might have made it too easy. C, excellent. I'll just give it another 5 seconds before jumping into the answer. B, B, A, all right. A, B, All right, so we've got few on A, there are few mentions of C, there's none mentioned in D, and there's majority going for B, which is really a correct answer. We don't consider harmonization as the part of getting the data from all these different sources to come together and work together, but like ultimately it's not integration, it's not ingestion, right? It's a separate step. And good pick up on the D being a funny one. All right, which DMO is required to be mapped for the unification and activation? And this is, I guess, testing your memory, whether or not you memorized that or paid attention when I was showing you the slides. D, B, C. That's an interesting one. I tried to make it a bit tricky. Okay, C. There's quite a few. It's a good mix of different options. But yeah, if you did pay attention, it would be contact point email. So we don't have a contact point Slack at this point. Account is not necessarily something that we talked about. The party, it was party identification. It was a plausible, but not really the right answer. So contact point email would be the right. All right, and the last one, what is the purpose of data normalization? This is, remember, talking about that normalized versus denormalized view. So what options would you choose? Or what answer would you choose for the purpose of normalization? All right, majority going with C. All righty, let's see. I thought that would be a bit trickier. All right, good job. I mean, this is it. It's not simplifying data exchange because that's the opposite of that. We prioritize data, but that's not on the business requirement. We're just really eliminating redundancy and ensuring consistency. So good job. I'll switch into Q&A. I've seen few questions.
So thanks for a very informative session, Vlad. Considering that it takes 20%, the ingestion and modeling takes 20% on the exam. So this is very important topic and there's a lot to cover. Thank you for summing it up very well. The questions that I remember from the chat are for the binary key, is there any limit on the number of characters that we can use?
Is there a limit for what, sorry?
The number of characters in the field value, I think.
Oh, number of characters. Yeah, so the field names are effectively, the number will evade me right now. There is a limit of how wide or how long the field name could be. Certainly, the system will tell you both on data ingestion when you configure data stream, and it will apply the same limit on the data model, and somewhere within like 30 characters plus minus, give or take, like 30, 40. It isn't documentation, but honestly, this is one thing that totally escaped my mind. So before you memorize that, go into documentation and have a look, because it does say what is the limit on the field name.
Sure, thanks, Vlad. And going back to the previous last question in the quest that you mentioned before, so can you elaborate on the contact point email, why it is the answer?
Certainly. So if you talk about contact point Slack, that doesn't exist. If you talk about account, that's one of the plausible options, but I've thrown it in because we looked at the individual, and I purposely remember, as I said, like which object would you choose? So I would accept account being the right one if you choose B. If you're talking about context of B2B, right? Because we do have unification on accounts available in the platform today, but because we didn't talk about that, I kind of hope that people just not necessarily sort of pay attention to that. The D was plausible correct answer. The only difference was, and one of the things that you need to remember is the object itself is party identification. So there's a difference between the party and party identification. They're two different things. In essence, the party itself is an attribute on a number of tables, or rather DMOs, including contact point email. And that is the field that is related. It's a foreign key to the individual ID. It is misnamed. It's really not the best way. And the reason for all of that was, if you look at the holistic data model and design, practically party meant to represent different entities, whether it's individual, accounts, households, any representation of the entity that will in some way engage with a business. We technically should have implemented a relationship that's supposed to be a party object, a party DMO. You have the party identification that is linked to the party, contact point, and all other objects linked to the party. And then there is a linkage between the party and individual and account and household and anything else. For whatever reason, we haven't really got to that level. And when we implemented, we didn't really, I guess, consider the account at the time to become that real entity that's going to be used in the identity resolution and a few other things. And therefore, it kind of goes into almost someone did a bit of a shortcut to say, well, we've got individual, we have party identification, we've got all these contact point details, we just link them straight into individual. But we've completely missed the fact that we need this one extra junction object that's supposed to become that translation between, well, you have this identifier that belongs to an entity, and that entity happens to be a person or a household, 2 or 3 people in a household, or a business entity. Like, that's the reason why party is not the correct answer. So party identification, yes, but party itself is a field. And that really leaves us with only contact point email as the answer.
That's great, Vlad. That helps clarify the question. We do have a couple of questions in the chat. I would like to check your availability. If you are available for the next 10 minutes, we'll continue. If not, we do have the Ask Me Anything panel. I can add those questions to the form.
Yeah, let me just go, because I've started seeing a couple of them. So I'll switch quickly back into the UI, because there's one question about user interface. So when you go into the data model tab, you have on the right hand side right here, there's a little drop down. You can see it as a list. So you've got the list of objects, or you've got graph. So graph is the view that gives you that view of these different entities in that sort of kind of like normalized, or rather, sorry, like a visual representation. And there's a way, oh yeah, there we go. Because I'm on the touchpad, sometimes it's difficult to zoom in, zoom out, but you can zoom in, zoom out, you can move them around, you can kind of drag them if you want and kind of restructure it. I find that useful when I do a quick check, specifically when I do configuration of some of the objects, and I want to verify that visually relationships are done correctly, because when you hover over any of the objects, it ultimately highlights the immediate relationship to it. And I can group them together, take a screenshot for my purposes. So that's majority of the time, that's my use of that. I find that convenient, sometimes work visually. The list view itself, most of the time, I think it defaults to the map, and most of the time you get confusion, like to say, hey, hold on a second, I'm not seeing anything in my view at this stage. So don't forget to switch to the all objects, and that will give you the list of all entities that are available in the system. Now, I would probably mention there's one more thing that I may or may not have spoken about. So if you see here, these are all definitions. The only mappings that you see is as soon as you see like booking here, you can see that there is a data stream and data lake object linked to it. And that sort of tells you like this is already configured object and configured entity. Now, if I go into the, let's just say, for example, booking, and I go into the visual interface and I say, I want to delete all the mappings. I want to get rid of them. I need to change something. There's a process that will tell you like, hold on, I should have gone into the data model. Sorry, data lake. Anyway, let it load. So the system will kind of tell you like, hey, this is currently used. And there are 2 different actions that you can take in order to remove the mapping. One of them, you can delete the object, and the other one is remove the mapping. There's 2 things, and you need to know that they are 2 different actions. So here, if I look at the at all of these different fields, I can click on any of the configuration, click delete. That's a field level mapping that if I want to remove. If I want to remove the whole entire object, I can remove the entire thing. Now you can see that the platform tells me pretty quickly, like, hey, you can't really use delete right now, or rather remove it, because you do have certain dependencies on that. So there's 2 options to consider. One of them is I can delete the object, and deleting the object is the data model object. For all the standard data model objects that you have in the system, deleting them doesn't actually delete the definition or the metadata of that object. Like the schema is going to be there, the object will be available for you to select and redeploy should you choose to come back and reconfigure. If I do want to delete something that is more custom, like booking object is a custom object in my system, if I delete it, it will delete it on the data model as a definition as well. On the left-hand side though, even if I delete it, the data will still be there because I'm not deleting data lake object, nor I'm deleting data stream object. They will still remain, but the system, because I'm removing all the mapping through deleting the object, will no longer be able to operate and access that. So that's the one thing to understand, like that deletion itself is what are you actually deleting? You're not deleting the data, you're deleting the instructions for the system how to represent that information. If you do have multiple objects linked to the data model entity, then you can remove the mapping for one of your data streams or data lake objects. The others will remain. And that's one of the ways to say, well, part of the information was used for testing or some purposes we no longer need it. We remove the mapping. The remaining mappings will remain, and therefore the system can still operate on the same object, but it will already exclude subset of data that was coming up through your modeling configuration. If you need to completely remove the information from the system, you'll have to go back to the data lake and data source and remove those items in order to kind of get rid of data in the platform altogether. So that hopefully answers the talking about the value suggestion, because I've seen there was an example of that. So let me look at, let's just say, one of the segments. Most of the time, the value suggestion is relevant for segmentation. So when I go, and it's a bit of a jumping ahead, but to connect the dots for you visually, yes, I do want to edit that. Ultimately, when you're configuring a particular attribute, you can type the value, like in my case here, my loyalty member points bucket here is equal to a particular value. So I can either type extreme, and there are some attributes where it's text and textual information, and I would not necessarily configure value suggestion. I will have to remember what value do I use in order to define the criteria for a segment. Or I can just click on that field. As you can see, I can choose from whatever system has configured as the value suggestion. Because in my data set, there's only 2 options available, then it just takes all of these pieces and creates a drop down for me. And they are dynamically created because I configured this attribute as one of these attributes that has specific set of values. There was another one that I can probably try to demonstrate you. There was I'll pass it in order to answer other questions. But yeah, ultimately this is just here. I don't believe that you can see value anywhere else. It's more making segmentation easier because you then don't have to remember, like, what did we actually use? Like, is it male, female, and genders? Is it age or age bucket? So you might have specific age buckets that were defined in some of the attributes, and you would be like guessing, is it like 20 to 25 or 25 to 30, instead of just actually selecting the value from the drop down. All right, what else was there?
Vlad, can you also touch upon how we unify the accounts? Let's say there are multiple accounts, just like the way we unify the customer record.
Yeah, unification for the accounts basically done on matching on the account attributes. So instead of individual, you map to the account data model object. And for contact points, you have email and address and phone. You don't have the social to like contact point sort of social or contact point app, because they don't really apply in the context of account. But the structural sort of behavior is quite similar, that you have account becoming your replacement for an individual entity. So that becomes your main object to begin with. And then for kind of matching itself, you'll have to have at least either address or email or phone defined in order to do the mapping between or rather matching. You can still use party identification, and all the relationship that you will start looking at just need to ensure that party field that exists in all of these different objects is now mapping to your account rather than to individual. So you'll have to make sure that this is configured too.
There's one more question related to this one, Vlad. So let's say a customer uses the individual table to be accounts for B2B usage. Then in that case, how are the contacts represented in the system? Let's say we have the partner representatives and so on.
I'll tell you honestly, this is not probably the right way to do that. You kind of ultimately, because if you look at that, there's an account entity, and the way you map it, so you've got account contacts, You've got contact itself that you can create should you need to do like a specific, just contact as a contact object per se. So there's plenty of different options, but I would not encourage to map account to the individual itself because it sort of doesn't make sense in the construct. If you think about mapping and modeling itself, your very first question should be what entity would be representative of the information that I'm trying to unify. So if you're looking into the B2B context, you'd be working on the accounts. And we do support account-based identity resolution, meaning that we recognize that instead of individual, we'll look into the account entity being your prime entity. And therefore, the mapping that you would normally go through, you would go account to the account contact to the account contact. So that's your contact mapping into the system, and they've got relationship between themselves. But we're not using your contact for resolution. We're using account level information for resolution. Your contact point address will be linked to the account address rather than individual address. I mean, that's where you can get a bit flexible, because ultimately you can say, well, even though I know that particular account is linked or has one address, but I know that some business representatives would have different addresses and we want to use them as one of the options to do recognition potentially, you can still do that. You'll have to figure out like some of the logistics between extracting these addresses and mapping them, maybe based on the account ID, but it is certainly one of the considerations to do. So all in all, I can't think of where would be appropriate to use individual as a mapping of account to individual. It simply kind of like would make it very complicated for you and probably wouldn't give you the right answers anyway.
Thanks, Vlad. So I see one question. Are the primary keys case sensitive? The values?
Case sensitive. No, I think, oh gosh, because I know, so for identity resolution, we have an option to do case sensitive match, but for primary key, oh gosh, that's a good puzzle question. I thought they're not, but I better check that. I'll have to take that one away. Oh, at least something I don't know for sure.
Curious question, Vlad. I haven't seen this in any of the documents. So for any of the primary keys, I haven't seen it being case sensitive in Marketing Cloud or anywhere. So
yeah, I mean, technically we shouldn't make it case sensitive. Like logistically from memory, the way everything was working, even for identity resolution, the system was treating it as case insensitive. So that was up until a certain point in time. Then we recognized, because even when we do CRM identifiers, and in some cases we actually want to enforce case sensitive comparison, and that's where the system now allows you to have that configuration. When you start going into unification, you go, okay, I want to use these particular attributes to match them, and I want to have case sensitive match. That is doable. It's done for identifiers, party identifiers, and therefore I would just conclude that for primary keys, it's case insensitive. It wouldn't care whether it's uppercase, lowercase, or mixed case.
That helps. Thanks, Vlad. So I think we covered almost all the questions here. And if any questions are left out, we can add to the Ask Me Anything form.
Yeah, I'm gonna pick up one because Raja asked a good question, just reiterating on the fact that you only need a single primary key. So that's the trick that you kind of go through, and most of the time you have to figure out, remembering that for my DMO mapping, for my modeling, I need to have one field that is going to be representative as a primary key for my model. If you do configuration of the data stream, it asks you for the exact same thing. What is the primary key on the data stream? But because they come from different systems, there's sometimes like it might be counterintuitive in a way, because you can have composite keys in the source system, and you need to express them somehow in the data cloud. So your starting point would be data stream. That's where you come in and say, okay, we do have, what did we use? Custom order and line item. So that stream is one of the examples. We actually generated the formula field that's using a concatenation of multiple fields. So we're taking the order number and the order line number from the source system that then generates us the value. So if I say this line item 12 and the order number is TRX005, and I can hopefully do the test. Because it's already in the configured, it doesn't do the test. So if I would test that, it should actually take the order number, do the underscore, and then put the line number item into the place. I can explore that in the Data Explorer and show you that what it does, but that's the way to go with it. So when we get the view at your data stream, when you're configuring it, the system will prompt you like nominate the primary key. You ideally, if you've done the exploratory work beforehand, you go, okay, I know I don't have a primary key as one field, I have a composite, but I do have all the fields available to me right here in the stream. So then the answer could be easy because you then define the formula field, concatenate them together, and that's your primary key. That's relatively easy because that's more or less what the composite key does. Just takes all these different values and concatenates them together. If you do need to combine like dates as part of that, you'll probably convert them to be text rather than date. Within the formula, there's conversion options, so you can manipulate it, but all in all, you end up with a string that represents in some way unique result. So that's one thing that is definitely doable, and by the virtue of that, because you only use one field to map it, by the time you go to the mapping, you will see that the system will ask you for primary key and you already have a design. The challenge could be is if you need to split one object, like one entry object, into multiple, like we looked at that contact that goes into 4 or 5 or 6 different other entities, and each of them need their own primary key, and you may or may not use the same value. So this is where you need to consider, do you have only one formula key, or do you might need to have like 4 or 5 or 6 formula keys in order to generate different values. I would normally, when I do design like that, I would normally suggest to create the formula field that matches your destination ID value. So I would say contact point email ID. I would say contact point phone ID. And when you go into the mapping interface, you straight away know which particular attribute matches to which particular DMO IDs, then because they're going to be the primary key values. So that's hopefully answers your question. And yeah, if anything else left out, just shout out when we get into like ask me anything or Q&A later, like in the offline mode. I'm sure that will be means and ways to answer all of these different questions for you.
Yeah, that brings us to the end of the session, and Vlad, I can't thank you enough. So every time I interact with you, my respect for you increases, and thanks for bringing great content in just 2 days notice, right? I just reached out to you 2 days ago and great content. And
it's all right. My pleasure. Thank you for having me. I hope that it was valuable. It's not too much information, but at the same time, it's a lot of good stuff that it is really important. I can't reiterate that data modeling is probably one of the most important and complex challenges in Data Cloud because it's intuitively easy to operate with. You've seen everything is because of user interface, but there's a lot of work that happens in the design to make it kind of right and accurate, and it does take effort and kind of thinking and testing and probing to figure out if you've done it correctly or not. So one of the big aspects for data model, we didn't really have a lot of time to go through that, but I would encourage you to explore because we do have that in the lesson. How do you use Data Explorer to verify your modeling and your mapping? Verify the results, look at the formula fields in Data Explorer to see what you've configured is ultimately coming up in the right way, and then start exploring like what are the attributes and how they look and how your model effectively is represented. Before you go further, I think that's one of the big things to say. Before you continue from modeling to any other configurations and activities, you have to have some kind of testing included into your configuration sort of plan, and that's something that we didn't cover. It's relatively easy to kind of figure out what to do. But yeah, that's it. Thank you very much, and enjoy the rest of the sessions that are coming through. I think that's quite exciting, and I think you're kind of approaching a really good point between configuring, preparing, and ultimately using the data for all the cool stuff. So looking forward to other sessions.
Yeah, thanks so much, Vlad. So we hope to see you again in the workshop. So
fingers crossed.
Anytime. Yeah,
totally.
Thank you very much.
All right, enjoy the rest of your day. Thank you, everyone.
Thank you. Bye.
Bye.